So the beer game on steroids, we named it because we're trying to do, we're using the lessons of the original traditional beer game. And I'm going to kind of jump around. If y'all got this deck, then you have this kind of information. It sounds like Sarah's already shared that with you. If you're not familiar with the beer game, it's a real simple supply system of a customer orders from a retailer, who orders from a wholesaler, who orders from a distributor, who orders from a factory. Factory delivers beer, cases of beer, distributor, wholesaler, retailer, all the way back up. So 4 entities in this supply chain. So factory, distributor, wholesaler, retailer. The only one making anything is the factory. And if you've played it before, this is a picture of people. Generally, it's played in person. Now there's a lot of online versions of the game, and some of them you can play as a group. Some of them you're just an individual. So there's plenty of these. Just look up beer game online, and you'll get options for that. But generally, when I use this in a course, when I use beer game on steroids, I'll start with the beer game, and we'll actually break into teams, and we'll play the beer game so that everyone feels that. Just kind of by, I don't know, show of hands or people saying anything, who all is familiar with the beer game already, the traditional beer game? All right, Fred says so. Okay, Shireen. All right. So a few of y'all, okay, Mark, thank you. And Nasim, okay, so perfect. So y'all are familiar with that. So all this will make sense. The lessons from the beer game, and the reason I'm walking through all this is because this is how we get to beer game on steroids. The lesson is, no matter who plays game, results are the same. The structure, essentially, I'm going to jump some slides here and stuff. The structure of the system is what generates the behavior. So the supply chain here is the system, and the structure, if you're familiar with system dynamics, which is the field where this comes from, we're actually using those kinds of models, simulation models, in beer game on steroids. But the idea is that the structure of the system generates its performance. So the structure of this supply chain generates the performance, and what everyone sees in the supply or the beer game is the bullwhip effect. And it doesn't matter who plays. Sarah could play, I could play, a high school student could play, a CFO could play. Doesn't matter who plays. The point is, the system is driving the performance, and not all the individuals in the system. And the system is made up of all these feedback loops, how inventory is controlled, all these policies, the delays, the shipping delays, things like that. All that makes up the, quote, structure of the system, and that's what's going to determine the performance. So the way they have it set up, it just so happens to create the bullwhip effect. That's not necessarily what every supply chain does or anything, but in the whole purpose of this was to create the bullwhip effect and all that. So what we did was we're taking that concept and saying, well, why not just let you do more than that? If you go look up beer game, the beer game, you'll find all these simulations of the beer game, and they're limited. They're just the exact same thing as the beer game. And we thought, yeah, but what if you want to have 20 companies in this supply chain and all that? So we have a commercial version of a tool that we use, and this is the free version. So again, if you didn't get that message, it's free, no cost to using this. Very easy, user friendly, or at least we believe it is. And the purpose is that you can go beyond the traditional beer game. So the lessons that you learn in the beer game, that the structure of the system generates behavior. In beer game on steroids, again, the structure of the system, the structure of this big supply chain you might put together is going to influence and guide and generate that behavior. So we want to understand, we want students to kind of learn, hey, under all these different conditions, here's how this supply chain responds, reacts, adjusts, recovers, whatever it might be, depending on the scenarios you run, and help students kind of develop this intuition for supply chains. Gosh, the longer the supply chain, if I've got 3 entities or 7 entities or 10 entities, the longer that supply chain, I see X. The shorter the supply chain, I see Y. The tighter my feedback loops, my inventory control, I'm trying to really be tight, then it causes these problems, or it has this advantage or whatever. And so we want to teach a little bit more of that. Plus the things we talk about in classes, we want to be able to show them and not just sort of point them out in a book or whatever and say, yeah, you know, if you do these kinds of things, it's good or bad. And we want to be able to show some of that. So that's how we got to Beer Game on Steroids. It's really not a game like the beer game. We just simply use that terminology so that people, since we use system dynamics as the underlying models, people from the field of system dynamics would recognize it and say, oh, beer game on steroids, let's check this out. So that's what we've done. Whoops, sorry, didn't mean to scroll so fast. There we go. The typical way that I use it, and we'll get to showing the beer game and answer any questions and all that in just a little bit here. But generally what I have done when I've used it is we play the original beer game, takes 4 people per team, and you kind of, you know, pit them against each other and, hey, everyone put in $1. Maybe you're not allowed to do that in school, but, you know, then there's this pot of money and the winning team gets it and all that. And so you kind of get them, you know, hey, we're competing against each other. So everyone's trying their best and all that. And so you play the game. Then what we do is we take those, you know, as a team, well, in this case, as individuals, you get Beer Game on Steroids on your computer, and you build the original beer game in Beer Game on Steroids. So you see, oh, that's what happened to us. We see the bullwhip effect. We see all that. So we end up replicating that. Then you have these teams of 4, however you end up doing it. This is just the way I've done it, and it seems to work, but, you know, do it however you want. But then I have those teams of 4 work as a team. So you always want, you know, students to learn how to work together and things like that. And so you give them all these additional scenarios to run. Now, I have them create those scenarios, but you could easily develop your own models and email that to them and say, start with this model and do blank to it, or whatever the case is. So it doesn't always have to be them creating. My examples are really, really simple, and so it's not that hard for them to use. So I'm also, of course, I teach them a little bit about the Beer Game on Steroids and how to do everything in the software. So, you know, for one of the sessions, we're sitting there walking through, and I'm teaching them how to navigate and how to drag and drop and do all this. So teach them how to use it. But anyway, have them run some scenarios. Everyone's doing the same one so that they can, you know, we can compare and all that. And so those are just additional scenarios with the traditional beer game. So far, we've still just been traditional beer game. So we have them change order patterns and all this kind of stuff. Well, then we go beyond that, and now we try to build something else. We add an additional distribution center. We take one away. We see if we have another factory that we're pulling from, does that help? All these sorts of things. So now you can get more complicated and you get beyond the beer game. And then they report, and, you know, so you have them writing stuff and getting graphics and all that. One thing, I don't know if I said, Sarah, in the presentation I did there, is we have you can visualize the results in Beer Game on Steroids. However, all that data you can just copy and go dump it in Excel. So what I do is create a template in Excel that, as long as they come and dump this, then it will calculate cost of inventory, whatever we want to keep track of. And so you can pull this into Excel. We're not trying to have all the visualization, great stuff. You know, that's we want to run we focus on the simulation, and then you can have some basic views or pull all that. So you always have that choice, is to pull it in that data and go look at it at somewhere else. So if you're from the field of system dynamics, there's this guy, Dr. John Sturman. He's number 2 in the field. Jay Forrester is the one that invented system dynamics back in 1958 or something like that. Been around a long time. Jay Forrester died, so John Sturman's kind of the top person. He's at MIT, the Sloan School of Management. And hang on, here's the actual. So, you know, I've got the book. It's probably not showing up too good. I've got a picture of it on the screen, but this is the Business Dynamics book that's in. It's chapter 18. At the back of the book, he's got a CD with all the models. So all I did was we just grabbed his model. So in our commercial version, we have much more complicated models. That's fine. But this is a very, very simple model. You can see it's really not much happening. In fact, if I just kind of lay this over, it's basically raw material gets produced into some finished goods, and those get delivered. And based on whatever I'm making orders to my suppliers, and then eventually those orders come back as deliveries. They come in as raw material. I produce stuff. We do have John Sturman's permission to use this, so that's also why we do it for free. Is this isn't our model; it's a publicly available model. So then in this widget, this production model. So this is our beer factory, or a factory. It doesn't have to be beer that it produces. It can be whatever. But these are the inputs that we allow. So these are certain things. There's lots of variables here, but we just let the inputs be a few of them. And these are the default values. So a manufacturing cycle time of 8 weeks, the inventory adjustment time of 8 weeks. I'm going to spread my orders over 8 weeks, things like that. And we have descriptions. When I walk through this, I describe a little bit more of what all is going on. But you're always welcome to buy the book and go look at it and learn as much as you want about the model in the book and what it's doing. For our warehouse, we just strip out all the production stuff, so it looks like this. And so instead, you just basically have finished goods, the equivalent of finished goods that get delivered, and I order and I get deliveries, but they just come to me as finished goods. I'm not doing anything. So there's two types of entities. You're either making something, or you're a warehouse that's passing something through. And so our methodology is we've sort of embedded these in icons. So the interface is actually dragging and dropping icons, but behind each icon is a model. And so as you're sitting there doing that, it's actually building a very large system dynamics model behind the scenes is what's happening. And this, these are just screenshots. This is an example. We'll get into the software here in just a little bit. This is showing that bullwhip effect. But now the idea is you go beyond the beer game. So instead of the very simple 4 entities, I have a ton of them. Do whatever you want, and you'll get these maybe some crazy, complex looking results. But you can trace through in the logic and say, well, the reason we see those results is this company did this, which caused this other company to do this, and caused this other company, based on their inventory policy, to react in a certain way. All that happens, and so you can trace through and learn. So a lot of times I'm looking at graphs and I'm like, oh, I wouldn't have expected that. But as I dig through, everybody in that, look at results for every company or entity in that supply chain. It's like, oh, that makes sense. I would not have thought that, but that's why we use computer simulation. So are there any questions up until this point? And I'll jump in and just start showing the software. Everybody good? Yeah, I see a couple of nodding heads. We'll go with that. Everyone else is muted, so that's fine. So let me stop sharing that, and now let me share this other. And y'all are now going to see me look over here. So my camera's here, but my screens are all over the place. So let me know if y'all see Beer Game on Steroids. Hopefully you do. So what I've done in this example is I've just recreated beer game, a traditional beer game. That's all I've done. So you got a factory, you got a distributor, you got a wholesaler, you got a retailer, and these are the icons. And I can drag any icon. I basically have this palette over here of customers, which is really just a demand pattern, a factory that makes something, or a warehouse that again just passes through. And if I select the factory, on this right side of the screen, you'll see the inputs, and these match what I showed you in the picture, and the values match and all that. And so that's where you start, but you could change any of these. So you could reduce cycle time and say, well, what does it mean if we reduce cycle time? Is that helpful? Under what conditions is that helpful? Does it make the supply chain brittle and non-resilient, or does it help? Well, anyway, ask all these questions you want. So you can play around with all that. Safety stock, things like that, how quickly we respond. If I look at the warehouse, I'm about to click the warehouse. So look at these values on the right. And when I click it, it's now a smaller set of values. So if you remember, we stripped out all the production stuff. So the variables related to production are not there anymore. So anyway, same, but they have the same values, the same thing. So there's the same basic model except for the production. So once you kind of learn what's happening, you know that. And if I select a customer, there's barely anything for the customer. All I'm doing is the customer says, where am I getting stuff? Who am I ordering from? And what am I ordering? And then it does that. So I'm going to get rid of, well, I'll show y'all also, once I have it here, you drag and connect, and that's all, that's what you do to kind of start building your model. So it's fairly simple in terms of what you're doing there. But let me get rid of all that stuff, get that off the screen, and let's just look at the beer game. So I've got a basic, I've already set this up where we're in steady state, nothing changed, just constant orders. And that's a good way to start learning about how any system, again, the supply chain is a system, is you want to start in equilibrium and just say, what's this look like? And for this to happen, what should everyone be holding? Based on their policies, how much inventory should they be holding? In this case, it's way up here at 400. So I can go through and I can tell you why that's 400 and all that. But point is, here we are, nice and steady. Then you introduce some kind of change and blip, you see how this whole system reacts and responds. And that's the whole idea of the beer game, is bump up demand and see what happens. So if I come over here, I take my customer, and all I'm doing is replicating the beer game at this point. And you can, it's just a little spreadsheet basically where you're telling it different time periods and what you want to do. And so, for example, I can delete that time period. So I start with 100 a week or time period, and then at week 10, I'm going to bump up to 120. Very simple, stepwise. That's the beer game. I come back to my results, I run them, and sure enough, I see the bullwhip effect. I see, if I were to trace through the different colors and all of these, I would see that the ones that don't oscillate much, that's the retailer, then your distributor and your wholesaler, and then this fuchsia line or magenta that's kind of really big is the factory having trouble at the end. But it's all just a little bump in demand. That's all it is. But now I can play around and I can, do other things. And what I was doing was coming in here. I'm going to add another time. I'm going to say at time 25. I'm going to drop it down to 90. So 100 to 120 back down to 90. These are just real simple patterns. And I see a different reaction. Okay, well, now we can trace through as to why things happened. And, this system that started in some level of equilibrium, even though my orders ended, they're in equilibrium steady right here, my system really as a whole doesn't settle down to that new level of steady state until much later in the simulation. So, just examples, y'all know all this stuff. I'm not trying to teach y'all anything. I'm just trying to show you how it comes across in the tool. And so that's kind of the very basic beer game. Then, like I said, you can get more complicated. So what I've done is created a system where I've got two factories at the far left. One of them is going through, and they're all producing the same thing, but I'm looking at basically two different supply chains. I kind of have a supply chain down here, and I kind of have a supply chain up here. And I've sort of laid it out so that the levels look the same. So I've kind of set this up rather nicely. But, again, you can do whatever you want and have 50 on here if you want. But factory produces something, passes through some warehouse, gets to another factory that changes it to something else. That factory has two customers, which are these two warehouses. And this is me, and I pull from this one warehouse or distributor, whatever you want to call it. You can come in here and just distribution center east. I can call it whatever I want here. You can go rename all this. I was just dropping some on there. But this is the only one that I pull from. I have a competitor that actually pulls from the same place I'm pulling from, but another one as well. There's another competitor that pulls from another couple, and then this competitor only pulls from this one. So I can now look at something much more complicated. And in this example, what I show is that, let me see if I've already, let me reset it. If I come in here, and for each of these suppliers, let me just drop them back down. These are my competitors, and we're just going to pretend like they're just sitting there doing nothing. So they're all doing 100. That's great. So they're just going to sit there at steady state at 100. And so I'm the only one that one's okay. I'm the only one that's introducing any kind of bump into the system. because I'm doing my beer game kind of thing. So I now go run that, and I see how everyone in the system responds. Not that much, obviously, because that's the only change. But what I'm also looking at in this particular case is my orders. Now I've zoomed in right here, and this is my jump from 100 to 120. And behind there, you can't see it. If I put this in table format, this now is all you do is grab all this and take it to Excel if you want to. But what I've done is I'm showing that you can't really see it, but when my orders go from 100 to 120, roughly, I mean, this is a continuous model, so you see fractions of things going through, but roughly this is saying, hey, you're unaffected by that change. However, if we now go back to our model, and let me get this back to that shipments page again, and now I'm going to pretend like my competitors are all having a big sale, and so they've doubled their orders, or at least two of them have. We're going to have these two right here. These two doubled their orders, and we're going to see what happens. So now I didn't change anything, but my competitors did. And if we go run the simulation now, we'll see what we saw before, some crazy lines. But what's interesting in this case is if I go look at my orders, I actually don't get everything I ordered, even though I didn't change anything. Because the supply chain, I mean, y'all know this, there's not infinite capacity. So my supplier is making decisions on, well, I'm going to kind of split my orders, and I'll give the most to the biggest customer and the least to the smallest customer. And so for a while, I'm actually impacted, even though I didn't change anything. And it's a great lesson to learn in supply chains is things ripple through. And just because you're ordering 100 from your supplier does not mean you're getting 100 from your supplier. That supplier's supplier has to give them 100, and that supplier's supplier has, and the whole thing has to work as a system. So anyway, I just wanted to show y'all some simple examples. You can completely create your own stuff. Glad to help you with those if you do, and your own scenarios that you want students to do. But that's kind of it. I'll leave it.